Right, first video then is on LDRs and thermistors. So an LDR, or a light dependent resistor, will alter its resistance in accordance with the amount of light there is outside. So as light increases, the resistance decreases. So when it's sunny and there's a lot of light, it will mean that there is less resistance across this branch here. So this is a parallel circuit, so ordinarily electrons would flow around and they'd have a choice, along there or along there. If these are equal resistance, the electrons will just equally split between the two. If this has got a lower resistance, what will happen is the electrons will find it easier to go along that pathway, so most electrons will go along there and less electrons choose this path. If this has got a high resistance, electrons will choose to go this way round because it's easier, so more light will, or more current will flow through the bulb. So when it's sunny, this has a low resistance. So the electrons will come along here and their easiest pathway is along here and round this way. That means that there is less current flowing through the bulb, so the bulb will be off. There will still be some, but not many. Okay, so this has a lower resistance, so this is the easier path. So most electrons will do that if there is a low resistance. So if it's light, this has got a low resistance, most current will flow through that, which means that less current flows through the bulb. So the bulb will be off. When it's dark outside, this has a high resistance. So the electrons, again, will move around. That has a high resistance, so most electrons will flow this way. So most current will go through the light bulb. That will then mean that because there's more current through the light bulb will turn on. So an LDR and a thermistor are both types of resistors that will alter their resistance in accordance with the climate they're in. So with an LDR, it will be to do whether it's light or dark, and with a thermistor, it's to do with temperature. I just realised here I've not coloured this in. So that's a high temperature, and that's a low temperature. Okay, so think of it a bit like a diversion sign of when the light needs to be off, it will be easier to go that way round, and when the light needs to be on, when it's dark, it will be harder to go that way round. So with a thermistor, as temperature increases, resistance decreases. So similar to this, as increases, resistance decreases. So as temperature increases, resistance decreases. So in this circuit, without looking at any of this on the right-hand side, if these were equal, electrons would choose, some would go that way, some would go that way, and it would be about 50-50. If this has got a high resistance, the electrons will choose this pathway instead because it's easier. And if this has got a low resistance, electrons will choose that path because it's easier. So if there's less resistance on here, okay, because it's hot, so there's less resistance on here, so electrons would prefer to take this path here. That means that there's less electrons going through the heat source. So most electrons are going this way around, so less current going through here, so the heater will be off. If it's colder, this has a higher resistance. So this time the electrons find it easier to go through this path. Because they're going through this path, they're going through the heater, so it turns the heating on. I hope that's helped.